Okay, welcome back to discussion of polarization. So in the last class, we have just introduced what is meant by a polarizer. Okay, so if you just review what we have discussed is the polarization is a phenomenon of confinement of the direction of oscillation of a wave into a one plane. So it is possible to convert a randomly oscillating transverse wave into an orderly oscillating transverse wave using a device or using a, a, a thing is called polarizer. Okay, so that we have discussed for a mechanical wave, that is basically the wave which is produced in a string. So today I'm going to discuss the polarization of light. Okay, now in order to discuss the polarization of light, first of all we should know what is a light. So I'm straight away going to the answer for it. So there are the different theories for the light. Okay, but I know to discuss the polarization phenomena, we have to treat the light is an electromagnetic wave. The answer is light is a electromagnetic wave. Okay, so what is the specialty of electromagnetic wave? So there are different specialty. It travels with the speed 3 into 10 raised to 8 million per second. So almost 300 million kilometer, a million meter per second. So that is the speed of an electromagnetic wave, and it does not require any medium. The propagation of electromagnetic wave is through the mutual reconciliation between the oscillation of the electric field and magnetic field. Okay, so the electric field and magnetic field are mutually helping for its propagation. So there is no requirement of any medium. But if you take in the example, the earlier example, we have taken a mechanical wave. So there actually the string is required to propagate the energy. So if you oscillate the one end of the string, the energy propagate only through the string. Okay, without string, if the string stops somewhere, then the energy cannot propagate further. That will stop there. But for the electromagnetic wave, there is no such string is required. There is no medium is required. Without the medium, the electromagnetic wave can propagate. So that is these are the some specialty of the electromagnetic wave, and it has very interesting property. The electromagnetic wave is a transverse wave. Okay, now the special thing is that it is a transverse wave, but there is no matter to oscillate. So what is oscillating in electromagnetic wave? So obviously it is the electric field and magnetic field. The oscillating quantity of the electromagnetic waves are the electric field and magnetic field. These are the oscillating thing. Okay, so we can have a schematic diagram of electromagnetic wave. Suppose this is the direction of propagation of an electromagnetic wave. Okay, then the electric field would oscillate. Okay, so consider a sinusoidal wave. Be very careful while drawing this. So the electric field will oscillate like this. So I'm just okay, let it be. So the electric fields. So actually I have just drawn the boundary of electric field vectors first. Thereafter I have drawn the electric field vectors inside it for more clarity. Okay, so this is actually what is your the electromagnetic wave, the electric field is. Okay, suppose this is the oscillation of electric field. Okay, now what about the magnetic field? The magnetic field would be perpendicular to both the direction of propagation. So this is the direction of propagation. So the magnetic field should be perpendicular to both direction of propagation, direction of oscillation of electric field. So the magnetic field will be oscillating like this. Okay, better. So I've just drawn the tip. I've just connected the tip of magnetic fields. Now I can draw the magnetic field vectors inside. Okay, so this would be a mental picture of the electromagnetic wave which is propagating in vacuum or in air. Okay, so it has a transverse nature. So now we have a question. Now the wave that I've drawn now, is it a polarized wave or an unpolarized wave? So here the people will have a slight confusion. The thing is, the electric fields are oscillating in vertical direction, and the magnetic fields are oscillating in horizontal direction. So obviously, the most of the people will answer that this is an example for an unpolarized wave, but that is not true. This is an example for a polarized wave. The thing is, you should, for the time being, for the discussion of polarized wave, for the time being, you just ignore about the presence of magnetic field because there are certain reason for it. Okay, I will discuss it later. Just ignore magnetic field because the thing is, the electromagnetic wave cannot exist without magnetic field. So wherever the electric field is there would be magnetic field. So whenever the electric field is present for electromagnetic wave, there should be accompanying magnetic field. മാഗ്നറ്റിക് ഫീൽഡ് ഇല്ലാതെ ഇലക്ട്രിക് ഫീൽഡിന് മാത്രം ഇലക്ട്രോമാഗ്നറ്റിക് വേവ് നിലനിൽക്കാൻ വേണ്ടി പറ്റില്ല. എപ്പോഴും ഇലക്ട്രിക് ഫീൽഡും മാഗ്നറ്റിക് ഫീൽഡും പെർപെൻഡിക്കുലർ തന്നെയായിരിക്കും. അപ്പം നമ്മുടെ ഡിസ്കഷന് തൽക്കാലം നമുക്ക് ഇലക്ട്രിക് ഫീൽഡ് മാത്രം കൺസിഡർ ചെയ്യാം. ദ റീസൺ ഈസ് സാധാരണ മെറ്റീരിയൽ ഇൻട്രാക്ഷനിൽ ദ മെറ്റീരിയൽ ഇൻട്രാക്ഷൻ വിൽ ബി സ്ട്രോങ്ങർ വിത്ത് ദ ഇലക്ട്രിക് ഫീൽഡ് rather than the magnetic field. Okay, so we can remove the electric field very easily rather than the magnetic field by with the interaction with the matter. അപ്പോൾ അതുകൊണ്ടാണ് തൽക്കാലത്തേക്ക് നമ്മുടെ ഡിസ്കഷനിൽ ഇലക്ട്രിക് ഫീൽഡ് മാത്രമാണ് നമ്മൾ കൺസിഡർ ചെയ്യാൻ വേണ്ടി പോകുന്നത്. Okay, so your electric field is oscillating in the vertical direction. So for the time being, so I will discuss, I will give the more importance for the oscillation of electric field, and I will just sightline the presence of magnetic field for the time being. So if the electric field oscillation is confined in a plane, then it is called a polarized wave. So this is an example for a polarized electromagnetic wave. So here the oscillation of the electric field is confined on one plane. Then how would be an unpolarized electromagnetic wave? Okay, so an unpolarized electromagnetic wave, if you look at an unpolarized electromagnetic wave, there will be oscillation of electric field along vertical direction. Obviously, there will be corresponding magnetic field in the horizontal direction, and there can be the electric field oscillation along horizontal direction as well. So if this is the case, if this is the case, then it is an example for an unpolarized electromagnetic wave. Now, obviously, there will be corresponding magnetic fields. So I have not drawn it now. Okay, if it is drawn, it will be big of full of confusion. So for the time being, I am not drawing it here. Okay, so this is just a picture of a polarized electromagnetic wave and unpolarized electromagnetic wave, and light is nothing but an electromagnetic wave. Now, how to convert a unpolarized electromagnetic wave into a polarized electromagnetic wave? So that would be our next question. Okay, so it can be done by blocking one oscillation of electric field. So in the earlier case, what I have done, in case of mechanical wave, we have blocked all horizontal oscillation using a vertical slit. and have just passed. We have just allowed the vertical oscillation to pass through it. So we can have a same mechanism. It is we have to stop one type of oscillation of electric field and we have to allow the other type of oscillation. So how will you do that? Okay, so there are different methods. So I am just discussing one simple method to you. The simple method is you can use an absorber, a good absorber. So an absorber is a material, or it's a device which can absorb electric field. Electric field absorb ചെയ്യാൻ പറ്റുന്ന ഒരു സാധനം വെച്ചുകൊടുത്താൽ മതി. And the best thing to absorb the energy of the electric field is metal conductor. ഒരു കണ്ടക്ടർ ഉപയോഗിച്ചിട്ട് അല്ലെങ്കിൽ മെറ്റൽ ഉപയോഗിച്ചിട്ട് നമുക്ക് എന്ത് ചെയ്യാം, ഇലക്ട്രിക് ഫീൽഡിന്റെ എനർജി നമുക്ക് അബ്സോർബ് ചെയ്തെടുക്കാൻ വേണ്ടി പറ്റും. So what you can do is you can just keep a a, mm, a grid of metals, a wire grid. Okay, so I will draw the wires. Okay, suppose we have kept a wire grid like this. Suppose you kept a wire grid in the path of unpolarized electromagnetic wave. Okay, so here the wire grid, inside the wire grid there will be plenty of electrons which can absorb the energy of electric field. So what this wire grid can do is this wire grid is placed in the horizontal directions, so therefore it can absorb all electric field parallel to the wire grid. So that means it can absorb all parallel electric field components of this electromagnetic wave. അപ്പോൾ വയർ ഗ്രിഡിന് പാരലായിട്ട് വരുന്ന ഏത് ഇലക്ട്രിക് ഫീൽഡും ഈ വയർ ഗ്രിഡിനെ അബ്സോർബ് ചെയ്യാൻ വേണ്ടി പറ്റും. വയർ ഗ്രിഡ് എങ്ങനെയാണ് അബ്സോർബ് ചെയ്യുന്നത്? ബിക്കോസ് ദിസ് വയർ ഗ്രിഡ് കണ്ടെയ്ൻസ്, if you look at this wire grid, if you look at this wire grid, so consider a small wire. It will have plenty of electrons inside it. It will have plenty of electrons. So if you apply an electric field, suppose some electric field come along this direction, what would happen? All these electron will absorb the energy of this electric field. Okay, so then what would happen? So here what would happen is this wire grid will absorb the parallel component of the electric field and it will pass only the vertical component. So only the vertical component will pass through it. So after the wire grid, we have only the vertical component of the electric field. So these all are electric field. It is not mechanical. So the people have slight confusion. So earlier, if you put a vertical slate, we got a vertical oscillation after that. But here we are putting a horizontal wire grid, but in this case we are blocking the horizontal oscillation and we are passing the vertical oscillations. So it is true, because what happens is the mechanism is entirely different. Here it is a mechanical wave and here we are blocking the horizontal oscillation mechanically, and in the second case it is an electrical wave, is an electromagnetic wave, and here we are blocking the horizontal oscillation of electric field by just absorbing it, and we have a vertical electric field after that. So we have an unpolarized electromagnetic wave on the left side and a polarized electromagnetic wave on the right side. So I have converted an unpolarized electromagnetic wave to a polarized electromagnetic wave using this small device, the wire grid. Now technically, what will you call for this wire grid? Technically, I will call this wire grid as a polarizer, because it has converted an unpolarized electromagnetic wave into a polarized electromagnetic wave. Now in this entire discussion we have just ignored the presence of magnetic field. So actually the magnetic field is present in all over this wave. Okay, so here there is a vertical electric field oscillation. There will be corresponding magnetic field oscillation in horizontal direction, and there is a horizontal electric field oscillation here. There will be corresponding vertical magnetic field oscillation also. So all the magnetic field oscillation is always present there, so that is why we have just ignored it. Otherwise the discussion will be very complicated. So that is why for the time being we just focus on how the electric fields are oscillating, and from that you can say that whether that electromagnetic wave is uh, polarized or not. Okay, so here the left side is unpolarized electromagnetic wave because electric fields are randomly oscillating. It has vertical direction, horizontal direction, so on. But after that, after it passed through the wire grid, we have a polarized electromagnetic wave, and the wire grid is acting as a polarizer. So this kind of polarizer is called, or here what we have done is we have polarized electromagnetic wave by absorbing some part of it. And this type of polarization is called the polarization by absorption. Okay, so this is a one method, and technically it is called dichorism or selective absorption. Now, this type of wire grid polarizer is not very effective. So that is why the people have found out a new technique to polarize electromagnetic wave, but using the same mechanism. The mechanism is same, but instead of wire grid, they used a molecule. So as a chemistry people or those who are in the chemistry main might be knowing about polymers. So certain polymers can have very high conductivity along one direction, and such polymers can be used instead of a wire grid to polarize an electromagnetic wave. So here this wire grid has a very high conductivity along one direction. That is, it can conduct the electricity only along this direction, the horizontal direction, and vertical direction there is no conduction. So we have a molecule, we have such molecules in our hand. So the people have done it, and such type of molecules or the sheet of such molecules are called, the polymers are called polaroid. Okay, so it is very famous, the polaroid glasses you might be knowing. Okay, polaroid. So polaroid is just the sheet of polymers, sheet of long chain of polymers, polymer, which is which are having very high conductivity along one direction as wire grid. So therefore, it can act as a polarizer of electromagnetic wave. So suppose if I have an unpolarized electromagnetic wave, unpolarized, and you kept a polarizer here. Okay, so the polarizer is can be polaroid. So this is an unpolarized electromagnetic wave, and we'll get a polarized electromagnetic wave. Okay. So now is a time to discuss graphical representation of a polarized electromagnetic wave and unpolarized electromagnetic wave. Okay. So for the graphical representation, I have to define a new definition called the plane of vibration and the plane of polarization. So we can just discuss, you can just introduce what is in by plane of vibration, plane of polarization, and we'll come back to the discussion of Polaroid. So the plane of vibration. So it is very straightforward. The plane of vibration is a plane which contains the direction of propagation and the plane of oscillation. Okay, so it's a very simple thing. So it is the plane containing, so in case of electromagnetic wave, the plane of oscillation of electric field and direction of propagation. Okay, so what is then plane of polarization? Okay, so we can have an example here better before doing that. So this is the x direction for the time being, x direction, and the electric field is oscillating along this direction. Or maybe this can be y. That's it. Okay, so what is the plane of vibration here? The electric fields are oscillating along y direction, and direction of propagation is along x direction. So obviously the plane of vibration, this example, is x-ray plane. And what about plane of polarization? Okay, so the plane of polarization is a plane which containing the direction of propagation and direction perpendicular to the plane of vibration. So this is basically the plane of polarization is a plane perpendicular to the plane of vibration and parallel to direction of propagation. So it is a plane containing, okay, it is not plane of oscillation, direction of oscillation. Direction of oscillation of, okay, sorry. So direction of propagation and and direction of no oscillation. I think that would be better. So it is a plane containing direction of propagation and direction of no oscillation. So here there is no oscillation along z direction and the propagation is along x direction. So the plane of polarization is xz plane. So some of you may have certain confusion about this terminology. Actually, this terminology is a very old terminology. In modern textbook and in modern literature, the plane of vibration and plane of polarization are same. Okay, but this is very old uh, uh, convention. Is we will take the vibration, the plane in which the vibration is confined as a plane of vibration, and the plane which is perpendicular to the plane of vibration is called the plane of polarization. Okay, but anyhow, in the modern literature, it is same. But there is not much of bothering about that. Okay, തൽക്കാലം നമുക്കിത് വലിയ ഒരു കാര്യമായിട്ട് കാണേണ്ട ആവശ്യമില്ല. നമുക്കിത് കുറച്ച് അങ്ങോട്ടും ഇങ്ങോട്ടും മാറിക്കഴിഞ്ഞാൽ വലിയ പ്രശ്നമൊന്നുമില്ല. Um, there are problems in certain cases, but anyhow, നിങ്ങൾ മറ്റ് ചില ടെക്സ്റ്റ് ബുക്കുകൾ നോക്കുമ്പോൾ പ്ലെയിൻ ഓഫ് വൈബ്രേഷനും പ്ലെയിൻ ഓഫ് പോളറൈസേഷനും സെയിം എന്ന് എടുത്തായിട്ട് കാണാം. പക്ഷെ നമ്മുടെ ടെക്സ്റ്റ് ബുക്കിൽ ഇത് രണ്ടും ഡിഫറെൻ്റ് ആണ്. ഇത് പഴയ ലിറ്ററേച്ചേഴ്സ് ആണ്. അപ്പം അതുകൊണ്ട് തൽക്കാലം നമ്മുടെ ആ ടെക്സ്റ്റ് ബുക്കിന്റെ രീതിയിൽ തന്നെ പോവാം. അതർവൈസ് വിൽ നോട്ട് ഗെറ്റ് മാർക്സ് ഓൺ യുവർ എക്സാമിനേഷൻ. ആൻഡ് അതുപോലെ തന്നെ ബാക്കി നമ്മുടെ ചില കാര്യങ്ങളൊക്കെ പറയുന്ന സമയത്ത് ഈ ടെർമിനോളജി നമുക്ക് വീണ്ടും വീണ്ടും ഉപയോഗിക്കേണ്ടി വരും. ഓക്കെ, നൗ so once you discuss the plane of vibration, plane of polarization, we can discuss the different the type of polarization. So there are basically two type of polarizations. One is called S type, another one is called P type. So consider an electromagnetic wave. It is incident at some plane. Okay, so let us have an electromagnetic wave come along this direction, and it incidents on some plane. Okay, maybe is air and is a glass. Okay, so this is the direction of propagation. Okay, and the normal to the glass is again along the same direction. So angle of incidence is 0 in this case. Now we can have two different type of oscillation for an electromagnetic wave. So either the electric field can oscillate along this direction, the one type, and which is the other type. Another type is the electromagnetic wave can oscillate along this direction. Okay. Now in the case of first one, the direction of oscillation of electric field is parallel to plane of incidence. I think you are familiar with the term the plane of incidence. The plane of incidence is a plane which containing the direction of propagation of light and the normal. Okay, I will just write here the plane of incidence is a plane which contains direction of propagation and normal. So normal is just the vector is perpendicular to the interface. Okay, just a line perpendicular to the interface is called normal. So that's it. So here, the first case, the plane of incidence is our boat, and the electric field is lying on this boat. So this type of wave, or this kind of polarization, is called the p-type polarization. Okay, so it is called p polarization, and p refers for parallel. Okay, and the graphically I will denote such type of polarization as a double-sided arrow. So this is the graphical representation of p-type. So the propagation of p-type polarization, I will just denote it like this. And the second type, here the oscillation of electric field is perpendicular to plane of incidence. Here the oscillation of electric field perpendicular to plane of incidence, and the name given for such type of polarization is S polarization. And why S not P? You can ask that, because S come from this word. It is a German word, Senkrest. Okay, Senkrest. Okay, so Senkrest is a German, and which means perpendicular. Okay, so that is why this type of wave is called S polarization wave, and graphically the S polarization wave denoted by a thick dot. Okay, so the P polarization denoted by a double-sided arrow, and S polarization denoted by thick dot. Then how would be an unpolarized wave? We can represent both. Okay, so if you consider an unpolarized wave, if it is unpolarized, how we can denote it? A thick dot with a double-sided arrow. So these represent this wave is an unpolarized. So it has both the P type and S type polarization. So we can go back to our previous discussion. It is a Polaroid. So suppose you have an unpolarized light here. So unpolarized light, we can graphically represent it in this fashion. Okay, and we have a Polaroid. Now in case of Polaroid, we can define an axis called pass axis. Suppose the pass axis is vertical. If pass axis is vertical, then it will pass only the vertical electric field, and it will block all horizontal component of electric field. So then after this Polaroid, what would be the notation of the polarized electromagnetic wave? Will you put dot or will you put double-sided arrow? Obviously, we have to put a double-sided arrow. Okay, because it will be passing only this vertical oscillation. All horizontal oscillation will be blocked. Great. Okay, so I have introduced a new term here, pass axis. So pass axis is an axis in which the electric field would be passed by the Polaroid. Okay, now the question, this question is now what would be the direction in which this Polaroid, which is having very high conductivity? So here this Polaroid are absorbing the horizontal component of the electric field. So obviously the Polaroid should have very high conductivity along the horizontal direction. Okay, so this Polaroid should have very high conductivity along this direction, like our the previous wire grid. We have aligned the wire grid in the horizontal direction. We have aligned the wire grid in the horizontal direction. So it is just absorbing all horizontal component of the electric field and passing the vertical component of the electric field. So the path axis of this Polaroid again, the path axis of this Polaroid is vertical. So this is the path axis. And again, in this question, the path axis is vertical, so it would be having very high conductivity in the horizontal direction. So that is why it is passing the vertical direction of electric field. Okay, so that's about for today. So what we have discussed till now is we have just started with what is a light, and to discuss the polarization, you have to treat the light as an electromagnetic wave which has both electric field component, magnetic field component, and all the electric field and magnetic field and direction of propagation would be always perpendicular to each other, and that is why the electromagnetic wave is called a transverse wave. And for transverse wave we can assign, or it is possible to polarize it. But the confusion part is there are two type of oscillation here: electric field oscillation, magnetic field oscillation. And for the simple discussion, just ignore about the presence of magnetic field, just think about the electric field, and we will further we'll discuss only about the electric field. So the electric fields are oscillating in all possible direction of an uh, a, of an electromagnetic wave, then that electromagnetic wave is called unpolarized. And if you can able to fix the direction of oscillation of electric field along one direction, then it is called a polarized electromagnetic wave. And we can do it by with the help of polarizer. And there are different types of polarizers. The one type that we have discussed here is a wire grid, so which absorbs uh, the the energy of electric field by using electrons or free electrons inside the conductor. Or another thing is a polaroid. The polaroid is also absorbing the electric field. Okay, so here the phenomena is called dichorism. It has selectively absorbs the one component of the electric field, and that is by the characteristic of a polymer. So some polymers which will be having very high conductivity along one direction, and that can be used as a polarizer. And the technical term for such polarizer are called the polaroid. And we have discussed how to graphically represent a polarized wave and unpolarized wave. For that we have just discussed we have just introduced a new terminology: the plane of vibration and plane of polarization. So if the plane of vibration, if the plane of vibration is parallel to the plane of incidence, then the wave is called the p polarized wave. And if the plane of vibration perpendicular to the plane of incidence, then it is called s polarized wave. And for unpolarized wave we'll have both. Okay, so the p polarized wave I'll be representing, the p polarized wave will be represented by using double sided arrow, and the s polarized wave by using a thick dot. So unpolarized wave will be represented in this way. So that's it for today. So with this we have completed the discussion of the just introduction of the polarization of light. And in the next lecture we'll be discussing the different ways to polarize an electromagnetic wave. So I've discussed one method, so there are many other methods, so we'll just list it out, and we'll discuss some of it. Okay, so thank you everyone, so we'll see in the next lecture.